All right, guys, so this is 7.2, ionic bonds and compounds. So we talked previously about the octet rule and broadly about how these atoms are going to bond, how they transfer electrons to another atom, and that creates a compound. What we're going to do today is really talk about how to make those compounds. So we used electron dot structures and a little bit of electron configuration to explain the charges of each group, and then how those groups and how they would like to achieve an octet. Do they lose electrons or do they gain electrons? So let's go through a recap a little bit. And this says we want to draw the electron dot diagram for potassium bonding with bromine. So the first thing we have to know right off the top, boom, potassium, where is it? Periodic table, potassium is over here. That means it's in group 1A. That means it's got a 1+ charge. Bromine, where is it? Over here in 7A. That means it's got a -1 charge. All right, that tells you how many electrons they're going to give away or receive. If they're going to be a +1, that means they're going to give away 1 electron. I'm going to give a negative electron away and leave me as a +1. Group 7A, I'm going to receive 1 negative electron and become -1. Okay, and the -1 and +1, that's your relationship between protons in your nucleus and electrons total. If I have 1 more electron because I gained 1, like bromine will, then protons, I've got a -1 charge. If I have 1 less electron, like potassium will, when it gives that 1 away, it'll be left with a 1 more proton, +1 charge. All right, so we know that potassium, since it's in group 1A, will have 1 valence electron. 1A, 1 valence electron. Bromine, group 7A, 7 valence electrons. How many do we want? 8. 8 valence electrons is the goal. And we know that potassium has a 8 hidden in that next shell underneath in its second energy level. And we showed that in electron configuration on the last notes. Okay, so potassium will actually give this electron to bromine just like that. That's the electron dot diagram. What that forms is now K with the +1 charge and Br with the -1 charge. We're going to talk today about what happens next. What do we need to draw next? Because we've drawn them, okay, I gave this one away, now I'm K+. I've taken this electron in, now I'm Br-. What now? Let's try another example where I've got calcium and oxygen. And I'm going to scrap that. Let's do calcium and nitrogen, because I want to do something a little different. All right, electron dot diagram. Calcium, Ca, it's in group 2A. 1, 2. Nitrogen is in group 5A. 1, 2, 3, 4, 5. Now, we did this last time where calcium donates that electron up there and donates this electron right here, but nitrogen needs 3. It's got 3 empty spots. So that means we need another calcium. Each calcium's bringing in 2 to the party. So it gives that 1 away, fills that spot. Great, but now this second calcium has 1 left to give away. It needs to give it away. I need another nitrogen. Boom. Puts that one right there. Same thing. That nitrogen has 2 more spots left over. Give me another calcium. Fills those 2 spots. So we needed 3 calciums and 2 nitrogens in order to make these guys bond together. And we end up with 3 Ca 2+. Each one of these gives away 2 electrons. And each one of these guys gains 3. So N3-. I'm going to show you a much easier way to do that today. But this is what we're thinking about. Giving away electrons, how many do I need? Nitrogen needed 3. Has to get 3. And if it wants to bond with calcium, it needs to find 3 calciums. And we need 1 more nitrogen as well. Okay, so 3 and 2. Okay, so our electron dot diagrams for bonding these atoms. So we're going to fine-tune our understanding today with bonding metals and nonmetals, talk about the properties of ionic compounds, and be able to write full-on chemical formulas, balance out the charges. So this is what we've been doing. We know that these ionic compounds form. Sodium gives that electron to chlorine, for example. And here's what we end up with. We actually end up with NaCl. But how that happens are the positives and negatives cancel out, because we've been writing it like this. Okay, that Na gives the electron, and now we have Na plus, and we have Cl minus because they gave them away. Well, take a look at this. When we have Na plus and we have Cl minus, +1 and -1 cancel each other out. A +1 charge and a -1 charge cancel each other out, and they leave you with just plain old NaCl. When we write chemical formulas, you do not want to have any charges. And we're going to steer away from these electron diagrams because they take up a lot of space. They're not super easy to draw and write very quickly. So we're going to start writing symbols with charges, because we know that everything in group 1A is going to be +1. Everything in group 2A, +2. Everything in 3A, +3. 5A, -3. 6A, -2. 7A, -1. If you don't already, you need to have those charges written on your periodic table, like I do up top here and up here. So we can find the element, boom, what's the charge? That's what we need to be able to do quickly. All right, so if we look at something like magnesium, our electron dot diagram, yeah, we've got a magnesium. It donates 2 electrons to that oxygen. That's going to leave us with Mg2 plus and O2 minus. 2 plus, 2 minus cancels out. We're left with just MgO. Now I'm going to jump ahead a little bit because I think we're ready for it. What happens like the one we just did where we had Ca and N? I needed 3 calciums. Ca2 plus, Ca2 plus, and Ca2 plus. And I needed 2 nitrogens. What's this going to leave me with? Oh, I needed 3 calciums, right? Ca, 3 of those. And 2 nitrogens, right? N2. That's what we would get. Ca3 and 2. That cancels out our charges. I needed 3 2 pluses and 2 3 minuses. Canceled it out. You can think of it as the least common multiple. If you got any math folks out there, this would give me a total of a 6 plus, right? 2 plus, plus 2 plus, plus 2 plus, 6 plus. This would give me a total of 6 minus, right? 3 minus and 3 minus gives us 6 minus. 6 plus, 6 minus cancels out. That's what we're looking for. I'll show you an even easier way here in a little bit. Even easier. All you have to do is know the charges and you're good. If you know Ca is 2 plus because it's in group 2A, done. And N is 3 minus because it's in 5A, done. Then you've got it. All right, so our goal today, cancel out the charges. Let's talk some vocab before we get there. Formula units. You're going to hear me say that a little bit. Okay, the unit of an ionic compound. Now, we call these things, I haven't even mentioned that yet, we call these ionic compounds. Okay, whenever you have a metal bonded with a nonmetal, it's an ion. It's called an ionic compound. So here we had calcium. Where's calcium on the periodic table? Is it to the left or to the right of the staircase? Here's my staircase. Calcium's over here. I think it's this one. No, I think it's this one. It's a metal. And what was the metal? Oxygen, I think. I believe is like right there. I think that's sulfur. It's one of those two. It's a non-metal. Metal and a non-metal. Get something from the left of the staircase and the right of the staircase. You get yourself an ionic compound is what we call it. Now, why would we call it an ionic compound? What's an ion? An ion is something with a charge, right? Well, why in the world would we call it that? Is because we have Ca2 plus. There's an ion, a cation, a positive ion. There is an ion, an anion or negative ion. So we call these ionic compounds because when they give electrons away and take electrons in, they turn into ions and they bond together and they become compounds. So here we have it, ionic compounds. Now, If I want 75 ionic compounds, I could say I want 75 formula units of this ionic compound. Formula unit is just the unit that we write after ionic compounds, just like we would write a little m for meters for length. Formula unit is the unit of an ionic compound. It sounds weird, it's a little funny. We're going to practice it, you'll get it. What that's defined as is the lowest whole number ratio of ions in an ionic compound. Really what that means is we're going to simplify. So check this out. I've got Ca, let's say I take Mg, which is 2 plus, right? And O, which is 2 minus. Just because it's 2 plus and 2 minus doesn't mean I write Mg2O2. No, I don't do that. We simplify. We want the simplest whole number ratio. I don't need 2 of each of them. I just need 1 because 2 plus and 2 minus cancels out. So if I have something that I can simplify, like 2 plus and 2 minus, I just write this as MgO. I just need 1 of each. The simplest whole number ratio in the compound. Okay, because when we change subscripts, the little numbers on the bottom, you completely change what that thing is. So let me give you an example. I've got 2 formula units of NaCl. 2 formula units of NaCl. I would not write it as Na2Cl2. That's not 2 formula units of NaCl. How we write it is with a coefficient out front. I want, dang it, this eraser. I want 2 out front, NaCl's, just like this. That's how we would write 2 formula units of NaCl. We would not change the subscripts and say 2 and 2. This is something completely different. All right, that changes the composition. For example, H2O is drinkable water. If I put H2O2, that's hydrogen peroxide. 2 completely different things. So we do not want to change subscripts, all right, unless we are needing more than one of them to balance out the charges. So if we want multiples of a formula unit, we use coefficients out front. We're going to practice that down there at the bottom. Okay. Last thing before we get into some bonding practice, ionic compounds, they behave the same. They're a group. Okay, whenever you get a metal and a nonmetal and bond them together, they start to have similar properties. We're always going to talk about the properties. Those are how things behave. It's how you can tell. Salt right here, NaCl, that's what this is. Metal and a nonmetal, this is an ionic compound. Ionic compounds are normally crystalline solids. This is a crystalline solid. It's got a crystal shape, and it's a solid. So one property of ionic compounds is that at room temperature, like it is right here, around 25 degrees, these things are solid at room temperature. Ionic compounds generally have high melting points. NaCl, its melting point, look it up. Well, Alexa, what's the melting point of sodium chloride?
Sodium chloride's melting point is 1,473.44 degrees Fahrenheit.
1,073.44 degrees Fahrenheit. 1,000 degrees you'd have to get this stuff to melt it. That's an extremely high melting point. Ionic compounds normally have high melting points. And ionic compounds can conduct electricity when dissolved in water. We're going to talk a lot about that. All right, for now, let's just remember it. If I put this stuff in water, boom, and I electrocuted this water, it would conduct electricity. If I touched it and electrocuted it, it would electrocute me. All right, electricity can flow through ionic compounds when they are dissolved in water. These are 3 very important properties. If you need to pause the video to write them down, do it, please, because you need to remember these. All right, I'm going to keep going for time's sake. If you needed to pause, that's great. We're back. So here's what we need to know. We already wrote this down yesterday, but we talked about 1A bonding with 7A. It's nice and easy, +1 -1. 2A bonding with 6A, nice and easy, +2 -2. Doesn't always have to happen that way, and we talked about that too. What we need to remember are charges. Group 1A, +1 charge. Group 2A metals, 2 plus charge. Group 7A metals, -1 charge. 6A metals, 2 minus charge. All of them. So we've got some groups, and we've got their charges. All right, now you've already written this down on your periodic tables. You don't necessarily have to write this table down unless you're filling in the actual notes. If you have them printed out, great, fill them in. But check this out. If you go to a periodic table and you did this, you've done the same thing. If you write +1, all of these are +1. Every single one in the group. All of these are +2, so on and so forth. So just make sure you have the charges on your periodic table, okay? Because we need to remember the charges. That is key. We're going to remember them so well that we're going to have a 5-minute quiz, probably multiple 5-minute quizzes next week when we're back in school on these metals and their charges. Okay, and I won't just say group 1A metals have what kind of charge. You already know those are +1. I'll say potassium has what charge. You need to know, boom, that's in group 1A, it's +1. Bromine, what charge? That's in group 7A, -1. Okay, we want to get those in here so that this is easy for us. Because if you know the charges, you can do this. All right, let's do some practice here. Pause it if you need to write down this table. That's fine with me, but we're going to keep it going. Now, the goal. When we form compounds, when things change, give electrons away or take electrons in, they make a neutral compound. Charges cancel out. You have to cancel out your charges. You will not have a 3+ bonding with something that's only 2-. Won't happen. You either need more of these 2- or more of these 3+ so that all your charges cancel out. Just like we did with, calcium and nitrogen. All right. So if we have something like potassium and oxygen, well, or I guess down here I changed it to sodium and oxygen. Okay, sodium and oxygen. Oxygen needs 2. Sodium's only got 1 to give. So I need 2 sodiums right here. 2 sodiums with 1 oxygen. That means I'm going to have Na2, because I need 2 sodiums, O. Na2O. That's what we would write as its formula. Okay, now let me give you an extreme shortcut. So you don't have to write out all of these charges. You don't have to write out all of these dot structures. Look at this. If you know the charges, if I know that lithium has a plus charge because it's in group 1A and iodine has a minus charge because it's in group 1A, and I know that when I write plus and minus, there's a 1 in front of those. You just don't have to write the 1. All you have to do is draw arrows like this to the subscripts, and that will tell you, the charges will tell you the subscripts of the opposite ion. 1 and 1. I only need 1 lithium and 1 iodine. 1 and 1. Let me show you again. In the second one, I know calcium is in group 2A, 2+. I know fluorine is in group 7A, 1-. If I draw arrows, that tells me that I need 1, because see that -1 right here? I need 1 calcium for every 2 fluorines. So I will have CaF2. The charges did it for us. See how that 2 down here, this 2 down here, it came from the 2+ opposite. No, see my arrow. The 1 that I don't even have to write because it's a 1. The 1 right there for calcium, it came from the charge opposite. So, sodium, what's the charge? +1. Nitrogen, what's the charge? 3-. Draw your arrows. That means I need 3 sodiums for every 1 nitrogen. Na3 N1. Done. If you know the charges, draw your arrows to tell you what the opposite atom subscript should be. This 3 came from the -3 up here. That told me I need 3 of the opposite atom and 1 of nitrogens. All right, pause the video. I want you to try D, E, and F. Okay, now I know these names are written out. Same thing. Just find the name. You can write the charge next to it. Draw your arrows. Same way. Pause it and try it. All right, let's get some answers here. So strontium, we should have found strontium hiding out in group 2A, 2 plus. Sulfur would be hiding out in 6A, 2 minus. Here's where simplest whole number ratio. Because when I draw my arrows, that tells me 2 and 2, right? I don't want 2 and 2. That simplifies. They cancel out. I just need 1 of each. 2 plus and 2 minus cancel each other out. So I would have SR, S. Just 1 of each. Beryllium, we would have found that hanging out in group 2A. Oxygen, would have found him hanging out in group 6A. Again, 2 plus and 2 minus. I don't want 2 and 2. BeO. If you have the same number, you just need 1 of each. You just want to cancel out the charges, so there's no charge. Now here's the tricky ones, because when you had magnesium, 2 plus. Phosphorus is in 5A, 3 minus. This is where we had 2 magnesiums with all these arrows drawn, 3 phosphorus maybe with all these, opposite. With all these arrows drawn. Don't have to do any of that now. Draw your arrows. Tells me I need Mg, 3. P, 2. Done. If you know the charges, you've got this. Okay, your charges should be on your periodic table. Make sure they're on there. All right, some more practice. This is just giving us practice with formula units. So it says we want 2 formula units when calcium bonds with nitrogen. So first, 2 plus, 3 minus. Tells me I need Ca3, N2. But it wants 2 formula units of them. I don't go by and change my subscripts and multiple, do any of that. I want 2 of those. 2 Ca3N2s. All right. Be hanging out in 2A. P hanging out in 5A. Boom, your arrows. It says I want 4 formula units of those. 4 Be3, P2. So now we're making our compound, but we need more than 1 of them. I need 2 of them. I need 4 of them. All right, pause the video briefly. Give yourself a try on C and D. All right, let's get some answers for C and D here. I'm going to write these charges out. I'm not even going to draw the arrows because I can imagine the arrows being drawn. All right, I need 1 formula unit. I never have to write the 1 for anything. So NaCl. 1 of those. K is plus. Oh, man, you guys paused it and you're probably all confused. I messed this one up. Strike me down. This is terrible. All right. You cannot bond 2 positives together. Can't happen. So let's take Al. Al can't be in here. Let's try N. How about N? 3 minus, because you need a positive and a negative. That's how they come together. 2 positives not going to work. 2 negatives not going to work. So potassium and then nitrogen. That would give me K. It says we want 9 formula units of them. 9. K3N. Man, my fault if there was any confusion. All right. So that's how we form compounds. Cancel out the charges. You have to know the charges so that you can write them, so that you can draw your arrows, so that you can cancel them out and write your formula. All right. Study guides. Work on those study guides. All right. That is 7.2.